Welcome back. In the previous video, we learned about binary data, which is zeros and ones that computers can understand, about character sets, which are predefined lists of characters represented by numbers, and finally about character encoding, which dictates how to represent a number in a character set as binary data. In this video, let's proceed to understand what are streams and buffers. Let's start with streams. A stream is a sequence of data that is being moved from one point to another over time. For example, a stream of data over the internet being moved from one computer to another, or a stream of data being transferred from one file to another within the same computer. In Node.js, the idea is to process streams of data in chunks as they arrive instead of waiting for the entire data to be available before processing. For example, if you're watching a video on YouTube, you don't wait for the entire video to be downloaded to watch it. The data arrives in chunks and you watch in chunks while the rest of the data arrives over time. Similarly, if you're transferring file contents from file A to file B, you don't wait for the entire file A content to be saved in temporary memory before moving it into file B. The contents arrive in chunks and you transfer in chunks while the remaining contents arrive over time. In doing so, you're preventing unnecessary data downloads and memory usage. And I'm sure you'll agree that is always good. Hopefully, it is clear to you now that a stream is a sequence of data that is being moved from one point to another over time. But the question is, how exactly is that sequence of data moved? That brings us to the next topic in this video, which is buffers. Now, to understand what a buffer is, I'm going to give an analogy that should hopefully be easy to understand. Consider the scenario of an amusement park with a roller coaster. The roller coaster can accommodate 30 people. But we don't know at what pace people arrive at the roller coaster. If 100 people arrive at a time, 30 are accommodated and the remaining 70 have to wait in line for next round. On the other hand, if only one person arrives, he or she has to wait in line for at least 10 people to arrive in total, and that is a guideline set to improve efficiency. But the bottom line is, you cannot control the pace at which people arrive. You can only decide when is the right time to send people on the ride. If people are already on the ride, or there are too few people to start the ride, you have to have people arriving wait in line. And as it turns out, this area where people wait is nothing but the buffer. Node.js cannot control the pace at which data arrives in the stream. It can only decide when is the right time to send the data for processing. If there is data already being processed or too little data to process, Node puts the arriving data in a buffer. It is an intentionally small area that Node maintains in the runtime to process a stream of data. A familiar example where you can see a buffer in action is when you're streaming a video online. If your internet connection is fast enough, the speed of the stream will be fast enough to instantly fill up the buffer and send it out for processing. That will repeat till the stream is finished. But if your connection is slow, after processing the first chunk of data that arrived, the video player will display a loading spinner which indicates it is waiting for more data to arrive. Once the buffer is filled up and the data is processed, the video player shows the video. While the video is playing, more data will continue to arrive and wait in the buffer. Hopefully, the concept of streams and buffers is now clear to you. Now then, what is the connection between binary data, character sets, and encoding we learned about in the previous video to buffers which we learned about a second ago? Well, to understand that, we need to head back to the editor and write some code. I'm here at an empty index.js. Now what you should know is that Node.js provides the buffer feature as a global feature that you can use without having to import it. Let's create a buffer that holds the string Vishwas. So const buffer is equal to new buffer. Now on buffer, we use a method .from which accepts a string Vishwas. We can also specify the character encoding, which is UTF-8. Now UTF-8 is the default encoding value, so that is optional. In the next line, I'm going to log buffer.toJSON. If we run node index, we see an object. Type is set to buffer, and we have a data array which contains 7 numbers. And this is our first connection to the previous video. Each number here is the Unicode character code for the character in the string Vishwas. Remember, 86 was the number for character V. Let's add another log statement. This time we log just buffer. If we run node index, we see this different representation of the buffer. And this is our second connection to the previous video. A buffer contains raw binary data that is displayed as output when we log to the console. But hang on, isn't binary just zeros and ones? Well, it is. What Node.js does is print the hexadecimal or base 16 notation of the number, as printing 8 bits binary for every character can flood your terminal. But if I copy 56, which is the representation of V, and head over to the browser, where I have a hexadecimal converter, and convert 56, we see 01010110, which is the binary representation of the character V and binary representation of the character code 86. If I would have tried to explain these log statements without any knowledge of the concepts from the previous video, I don't think I would have been able to explain what a buffer holds. But hopefully you now understand. Now you can also log buffer.toString, and this will give back the string representation of the binary data in the buffer, Vishwas. Now you can also write to the buffer. So buffer.write, and let's pass in the string code. If we rerun node index, we see that the string is now code was. And this is because buffers have limited memory. The 4 characters overwrite the 4 characters from Vishwas. And if you were to write code evolution, run node index, you can see the last few letters are skipped as they can't be stored in the buffer. Hopefully, you now know what are buffers and how to interact with them in Node.js. But let me tell you something. Node.js internally uses buffers where required, and you may never have to work with buffers directly. In fact, we could have learned about FS and HTTP modules without understanding about buffers in this level of detail. But as always, I would like you to understand the foundations as they are key to forming a mental model of any technology that you're learning. Alright, in the next video, let's learn about asynchronous JavaScript. Thank you for watching. Please do consider subscribing to the channel, and I'll see you in the next one.